Assalamualaikum and hi everyone. So we are going to take a look at the first subtopic for chapter 6, which is the integration of exponential function. So for integration of exponential function, we are going to focus on two types of function. The first one is e power of x or e power of ax plus b. As for the second one, we are going to take a look at the simple index function where we have a power of x or a power of mx plus n. Okay, so before we start, we are going to recap first from what we have learned in chapter 3, which is the differentiation of exponential function. For differentiation of exponential function, what we did previously was d by dx of e power of x will give us 2 bracket, where the actual concept is that we are going to have another bracket, but this bracket will always be 1. Why? Because we use the concept of copy, differentiate, and taking the ln of our base. So if you take a look, we will have here ln of e, and this will always be 1. So that is why we just remove the third bracket and we use the first two only. So by using the first two brackets, we are going to have first copy everything. So we have e power of x, and then differentiate our power will give us 1. So by using the concept of antiderivative, what we have learned in chapter 5, okay, what we are going to have is if I integrate e power of x dx, then that will give me whatever in my left hand side, and that will be e power of x plus c. Okay, so what actually happened here is the second bracket here for differentiate power, we will bring it to the other side. So the first bracket copy everything, and the second bracket is differentiate, and the third bracket is here. So in this simple case, these two brackets will be 1. So e power of x over 1 times 1 is still 1 plus c, and hence our answer for integral of e power of x dx will give me e power of x plus c. It is the same as the other case where if I have d by dx of a power of x, then what we will have is 3 brackets. The first bracket is copy everything and then differentiate power and taking the ln of our base. So in this case, copy everything will give me a power of x, differentiate my power will give me 1, and ln of my base will be ln a. Ln a is a constant. Please take note. Okay, so what we are going to do now is still using the concept of antiderivative. Then we can rewrite if I want to integrate a power of x, then what I'm going to get is my left hand side, which is still a power of x, but it will take over this bracket. So ln a will be brought to the left and it will be on the denominator. So ln a, it is the same for the second bracket, but since it is 1, I don't need to show, but I'll just write it there. So 1 times ln a, and then we are going to put at c there. So the simplification for the integral of a power of x dx will give me a power of x divided by ln a plus c. Okay guys, so I hope you can understand the concept. So now let's take a look at the full concept for integration of exponential function. So for integration, this one is with base e and the other form is with base a, where a can be any number. So how do we integrate these functions? The first one, if you integrate e power of x dx, then using the 3 brackets concept, we will then have the first bracket is on top and the other 2 bracket is at the denominator. And then please don't forget to put at c. So what are these 3 brackets? First, we just copy all, divided by the derivative of our power, and then multiply that by the ln of our base. So again, in this case, this third bracket can be removed. We are not going to use that. So practically we will have only 2 brackets, which is c divided by d. So if we fill in, we will have e power of x over 1 plus c, and hence we can rewrite that as integral of e power of x dx is actually equals to e power of x itself added by c. Okay, so next, if I integrate e to the power of ax dx, then what am I going to get there is the first bracket, we just copy everything and then divided by the derivative of the power, which is a, and then we add c. So we can also rewrite that as is actually equals to 1 over a times e power of ax plus c. And in the other case, where my power is not only ax, but if I have integral of e power of ax plus b dx, then my answer will be in the similar form as the second one, where I will have e power of ax plus b divided by differentiating my power will give me a and then plus c, or we can also rewrite that as is equal to 1 over a e power of ax plus b, and then we add c at the back. Okay, so please take note of those integrals. So now let's take a look for the case where I have the integral of a power of x dx. How do I integrate this? So again, using the same concept, but right now we are going to have exactly 3 brackets. You cannot remove any of them. Then what we will have here is we are going to have copy everything on top on our numerator, and then the other 2 brackets will be d and l on our denominator. So filling in those brackets will give me a power of x on top, and then I will have 1 and ln a. So simplifying that will give me integral of ax dx will give me 1 over ln a times a power of x plus c, or we can just rewrite that a power of x over ln a plus c. Okay. Next, what if I have integral of a power of mx plus n? So what I will have here is the same as previously, but the one that will be different is the second bracket here. Okay, this one will be different. So now let's take a look. If I integrate this, I will have 3 brackets. So the first one will be a power of mx plus n. And then differentiating my power will not give me 1, but I will have m here, and then this one will be the same. It is ln a. So the simplification of my answer will give me integral of a power of mx plus n dx actually equals to a power of mx plus n divided by m times ln a, and then we will add c at the back. Okay, so I'm going to stop there for the simple concepts, and then let's discuss some of the examples before I let you try the other examples by yourself. Okay, so as for the example, let's take a look at example 1. Example 1a, we need to find the integral of e power of 2x. So in this case, we are going to copy everything, e power of 2x, and divide by the value in front of x. So we will have 2, and then plus c. As for the next question, take a look at question B. You need to integrate e power of 2 plus e to the power of negative x dx. So please take note, e squared, this is a constant. Since this is a constant, what we are going to have there is the constant will be multiplied by x. It is the same as what you had previously where we integrate 2 dx. Then you will have 2x plus c. So using this very similar concept, we are going to have here the integral of e square will give me e square times x, and then plus integral of e power of negative x will give me e power of negative x divided by negative 1, and then plus c. So simplify your answer and you will have e square x minus 1 over e power of x plus c. So now let's take a look at question D. How do we simplify question D before we integrate? You need to integrate 1 plus e power of 2x over power of x dx. So in this case, if you want to integrate this, you need to separate it. So you will have integral of 1 over e power of x plus e power of 2x over e power of x dx. So using the concept of indices, you will have this one integral of e power of negative x and then plus e power of x dx. Integrating that will give me e power of negative x divided by negative 1 plus e power of x plus c. So we can just rewrite our answer negative 1 over e power of x plus e power of x plus c, and just leave it at that. So I will leave you with question C and E. Please try yourself. Okay, thank you.